Hello everyone, it is time for our Chapter 7 review, Part 2. This time, it's proportional. Alright, to get us started here, let's take a look at our first problem. The first thing we're going to be looking at is here in number 1, carpentry. Jake is fixing an A-frame. That's what this type of device is called over here. If you're setting up something made out of wood, you're making an A-frame. Could be made out of something else. He wants to add a horizontal support beam halfway up and parallel to the ground. How long should this beam be? So we're told it's an A-frame, we're told this is halfway up, he wants to build that, and that it's going to be parallel to the ground, and we're told that the ground, separating these two legs of our triangle here, if you notice, we're building a triangle, but out in the real world, the base here is 8 feet long. So let's take a look at how to do this problem. As per normal, if you want to pause here and figure it out on your own before I explain how to do it, go ahead and pause right now. Okay, so the first thing we're going to do is we're going to set up some labels for each of these points here, A, B, C, D, and E, so that we can reference each segment of our figure. So I'm going to put that over here in the corner so that we can look at it clearly while we're doing this problem. And the first step, as we've already done, is to label it. So the next thing that we need to do is to set up our proportion. But before we go on trying to figure out what our proportions are, notice that we're dealing with something that we're told is halfway up our figure here. So it's halfway up our A-frame, and it's parallel to this base here. And we have a rule, it's called the mid-segment theorem, which states that if our mid-segment, BE, is parallel to our base, CD, then at BE will equal 1/2 of CD. So, since we have CD being 8 feet long, our mid-segment up here will be 4 feet long. So, that's a proportion if we were going to set it up. We don't have any of the figures that we need here, BE being mid-segment, CD being our base, and we could try and use our segments of our A-frame here to figure it out, but because we have this handy-dandy theorem, we don't have to do any more work than to just know that this is going to be half of this down here. Problem number 2, again, if you'd like to pause and work it out on your own, it says that streets in the diagram, K Street and Bay Street, are parallel. Find X. So here's K Street, here's Bay Street, here's some intersecting streets, and it wants you to find X. So if you want to work it out, pause now. Okay, putting that up in the corner over here, let's work through how to find X on this problem. We have to remember that we have to set up our proportions, and our proportions work this way. Since we have two parallel lines running through these transversals here, we're actually creating proportional segments of these lines. So we've got 1 kilometer over 0.8 kilometers. Here's our first ratio. But we've also got 1.4 kilometers over x. So here's our second ratio, setting up our proportion. 1 over 0.8 equals 1.4 over x. Remember, we can do this because we have parallel lines with transversals running through them. So once we've set up our proportion, then we cross multiply, our old friend that all of you should be getting used to by now. How to cross multiply? Well, we just take each portion here, we take the x and we multiply it by 1, which leaves us with x. Then we take the 0.8 and the 1.4 and we multiply those together over here, leaving us with an answer of x equals 1.12 kilometers. Next problem. So we have here the jungle gyms. Prasad is building a 2-story jungle gym according to the plan shown. Find X. So again, here we're working with parallel lines. This time we have 3 parallel lines with transversal lines. Notice that that's exactly what these are, even though these represent real figures in real life, things that are being built, we have lines intersecting other lines. So we've got an 8-foot segment here and a 10-foot segment here. Since these are parallel to each other and there is no change in the direction or the slope of any of this, this one's also 8 and 10 feet. That proves to you that these are parallel when this is remaining constant here. But we have this line over in this direction, which is going to interrupt that, and we've got a 24-foot line going this way. So when we do that, we are searching for X now. We still have these proportional segments that are cutting it, but we're not going to end up with that 8-foot and 10-foot anymore. Notice that if you took this line and you ran it just horizontally down, it does not add up to the 18 feet that these add up to. It adds up to 24 feet. So let's figure out how we can get X off of this here using the proportions that we set up now. Okay. So we want to set up our proportions. The first one, we have 24 minus x. Notice that the entire thing is 24. If we eliminate this x from it, then we're only left with this section over here. So this part is actually corresponding to the 8s over here. So we've got 24 minus x corresponding with 8 across the equal symbol over here. At the bottom part of our proportion, we've got x here. So it's 24 minus x over x, creating one ratio. Our second ratio is obviously 8 over 10. So the x corresponds with the 10s, and the 24 minus x corresponds with the 8 over here. But we can simplify this a little bit, because 8 over 10 is not a simplified number. So let's rewrite it as 24 minus x over x equals 4 over 5. Notice that just took out a 2 from these, so that this is divided by 2, ending up with 4. 10 divided by 2, ending up with 5. 4 over 5 is the same thing as 8 over 10 when we're talking about fractions, when we're talking about ratios. So once it's simplified, we can then bring it over here to cross multiply once again. All right, so once we've cross multiplied, we've got the x times 4, and we've got the 5 times 24 minus x. So let's figure out what our products are. We've got 4x equals 120 minus 5x. Once we collect our like terms, we then take this negative 5, adding it to both sides, getting 9x, canceling it out over here. 9x equals 120. So the next step is to isolate our variable x by dividing both sides by 9. We divide this side by 9 and the 9's cancel out. We divide 120 by 9 and we end up with x equals 13 feet and 4 inches. Notice what happened here. We didn't end up with a decimal as our answer. If you put this into a calculator to try and find it, you're going to end up with 13 point something something something, and if you remember to put it back into its actual measurement here, you'll say 13 point something feet. But the answer that they're looking for in the worksheet that we're going through right now wants it in feet and inches. So in any problem that asks for something like that, we're going to put it into feet and inches, and you have to be able to actually do the division, guys. Don't rely on the calculator too much. There are plenty of times where it will help you, and there are plenty of times where it will give you an answer that won't just be acceptable to what we're looking for on the problem. So when you divide 120 by 9, it will go into 120 13 times with a remainder here. So this remainder ends up being 4 inches, and you have to remember that there are 12 inches in every foot in order to get to this answer. And we'll do a problem where we do a little bit of that later. But notice that we ended up with feet and inches in our answer. X equals 13 feet, 4 inches. Next problem here. Playground. The playground at Hank's school has a large right triangle painted on the ground. Hank starts at the right angle corner and walks towards the opposite side along an angled bisector and stops when he gets to the hypotenuse. So he starts over at this corner and walks all the way to the hypotenuse. How farther from Hank is point B versus point A? So notice something about this problem. We're not just figuring out the length of each of these segments. We're actually figuring out the difference between the lengths of these segments. We're given the total length as 50. We have to figure out the length of this segment, the length of that segment, and then determine the difference between the two. In other words, how much closer is he to A than he is to B, or how much farther, it says, from B is he than A. So go ahead and pause here if you want to work on it on your own, and let's move forward. All right, you'll notice here that I've drawn out some lines here to indicate what we're talking about. The green lightsaber there is X, the red lightsaber is 50 minus X. Well, how did we get those? Well, X is what we're looking for over here. 50 minus X, if you remember how we do these problems, is how it's set up. If you have 50 as the total, and you know that this is X, which we don't know yet, then this must be whatever 50 minus X is. All right, so we're going to set up our ratio, and we have our X over 50 minus X for our first ratio. And then to set up our proportion, we take our sides here of 30 feet and 40 feet, setting up our second ratio, 30 over 40, the full proportion being X over 50 minus X equals 30 over 40. But we can actually simplify this. 30 over 40 can be reduced down, so we simplify it. 30 over 40 can actually be written out as 3 over 4. So let's go ahead and do that and then set up our new proportion. Our simplified proportion would be X over 50 minus X equals 3 over 4. Okay, so now we have that. X over 50 minus X equals 3 over 4. Let's continue on trying to figure out the problem. What do we do once we have our proportion set up? Why, we cross multiply. So if we set that up here, we then get 4 times X on this side of the equation and 3 times 50 minus X on the opposite side of the equation. So once we produce that, we get 4X equals 150 minus 3X. All right. Then we want to combine our like terms, so we want to get this minus 3x on this other side. The way we'll do that is by adding 3x to both sides of the equation, and we end up with 7x equals 150. Then to get x alone, we have to divide both sides by 7, so we'll end up with x equals 150 divided by 7. So here's another instance where we're going to go ahead and actually divide that out rather than put it in the calculator, because we end up with x equals 21 and 3/7 feet. Okay, so that's x. X over here is 21 feet and 3/7. So we've found x, but what about this distance over here, 50 minus x? Well, we could reset up everything again, set this for a new variable of y or something else, and put it all in this all over again, trying to figure it out and cross multiplying. Or, because we have the total of 50, we could just subtract x from 50. Right? That's what we have over here. That's the length of this side. So what did we get for x? We got 21 and 3/7. So if we have 50 minus 21 and 3/7, what do we end up with then? Well, we end up with 28 and 4/7. Notice the 4/7 and the 3/7 will add together to 7 over 7, or a whole number of 1. So 28, 21, that should give us 49 plus 4/7 and 3/7 equaling 1 gets us back to 50. So this side over here, 50 minus x equals 28 and 4/7 feet. All right, so what is our final answer then? Notice I put over here, we have 21 and 3/7 feet, 28 and 4/7 feet. We're not done because we're not asked just what is x or what is this distance over here, which we called y for a second. No, no, no. We are actually asked, what is the difference between the two? How much farther away from B is Hank than he is from A? Or how much closer is he to A than he is from B? That's the final question, the final answer here. And so we do that by actually subtracting again. We can actually find the difference between the two by taking the larger number and subtracting our smaller number from it. And we'll end up with 28 and 4/7 minus 21 and 3/7. And we end up with 7 and 1/7 feet. And that is the difference. That's how much farther away Hank is from point B than he is from point A when he stands right here. Okay, let's go back to this problem once again. You thought we were done. That was the final answer, right? Well, almost, because I actually want to show you a different way how to do this problem. The way that we just did the problem is the way that your book will show you how to do it. It's the way that we can do it through all of our worksheets, and if you find that way acceptable, it's an easy way to do it. But it has a few extra steps that we can actually circumvent. Later in the book, when we do proportions, we're going to go over this type of method that I'm going to show you right now. It just goes to show you that there are multiple ways to get the right answer in any sort of math, but we do need to check to make sure and verify that we've gotten the right answer. Let's see this different method and see which one you prefer to use. Okay? So if we set up our equation once again, let's examine the ratio in the concept of putting in the numerator what we want to solve for over the total that we have. So if we're looking again at this, we have a total of 50, and we want to get to the x and then the difference between these two. So let's set this up. If we have 50, setting up our proportion again, or attempting to, we have 50, and we have 30 over 40 as our ratio. Well, we simplify that to 3/4 just like we did before, and we end up with 50 equals 3/4. But wait a second, here's a problem here. This 50 is just a whole number. That's not set up as a ratio. There's no real proportion set up here yet. We just have the total of 50, and we have this ratio of 3/4. We have those things, but we don't have it set up in a way that we can actually use it yet. So let's examine what exactly we have when we're talking about these 3/4 over here. What does it mean that it is proportional by 3/4, that we have a ratio of 3/4? So we take the fact that there are 3 parts and 4 parts. There are different parts of this. Now, this doesn't mean that this is going to work out mathematically, that this is always 3 over 4. You can't just like find 1/3 of 50 and try and work it out. It's not going to work out that way. That's not the way the math will work out. But we do have 3 parts over 4 parts in our ratio there. That's important because we're actually going to figure out that we have a total of 7 units, 7 parts that add up to this 3/4. When you add 3 and 4, you get a total of 7. While the total length is 50, the total number of parts is 7. So let's set up that ratio this time. Again, we want to solve over the total. We have our 7 parts and we have our 50. So here we're keeping it together. It's the reason that I have it set up this way is so that you can see what's in the denominator of both and what's in the numerator of both. Here at the bottom we have a total of 50, and here at the bottom of this ratio we have a total of 7. Okay? And here over the 50, we're trying to figure out what the actual length is, what the actual distance is right here of these 3 parts. And on this side, of the total of 7 parts, we have 3 parts as the numerator. So we have the 3 over 7 as this side of our proportion, and we have x over 50 as this side of our proportion because we're trying to find that length right there. And then we do the process of cross multiplication once again. Just a little bit simpler than the last time that we did it. Now we have 7 times x, so 7x appears on this side of the equation. On this side of the equation, we have 50 times 3, or 3 times 50, and we end up with 7x equals 50. Now, if that looks similar to you, then you've been paying attention because that's the exact same thing that we got working it through the other time. And the other side of this page, we did the exact same thing coming up to 7x equals 150. We just took about 3 extra minutes to get here. So we can do it this way to simplify it. Now, if this way totally confuses you, you don't have to do it this way. We will be doing more of these when we get later into other chapters, but you can do it the way that the book shows. I think it's important to know both ways. So that's why I'm showing you this way. Now, again, once we reach this step, you then divide both sides by 7, and you end up with the exact same answer that we got before of 21 and 3/7 feet for x. Down here, the 4 parts of y, we could repeat this once again, just like I said before with the other one, using y. This time it would be 4 in the numerator, setting it up that way. But, you know, we really don't have to go through and do all of that because we know that 50 minus the answer that we got for x is equal to y. And the answer that we get for y is 28 and 4/7 feet, just like we got before. So this section right here, we know that we got the right answer because we solved it 2 different ways. We got the same answer both ways. That's one of the important reasons why it's good to know different ways to solve problems in math, because if you're having trouble one way or you are kind of skeptical that you got the right answer, you can try solving it a different way and see if you get the same answer, and that's one way to verify that you've gotten the right answer or not. All right? Let's take a look here. Remember that we're not done. We're not done because we weren't just trying to solve for x and trying to solve for y. We were trying to solve for the difference. So the difference between the two, just like before, is done through subtraction. 28 and 3/7 minus 21 and 3/7 equals our real final answer, which matches our final answer from before, 7 and 1/7 feet. All right, next problem, guys. Gordon made a photocopy of a page from his geometry book to enlarge one of the figures. The actual figure that he copied is shown below. All right, so we've got our triangle here with a median and an altitude. We've got the length of the base as 39 millimeters. We've got the length of the median as 30 millimeters and the length of the altitude as 29 millimeters. All right. Then the problem continues by saying the photocopy came out poorly. Gordon could not read the numbers on the photocopy, although the triangle itself was clear. Gordon measured the base of the enlarged triangle and found it to be 200 millimeters. Okay, so he's making a copy of this. There's going to be an enlargement to this. Remember, enlargement just means it's the exact same figure, just blown up. So it's going to be a scale bigger than this. So it won't be equal to 39. He actually measured it and got to 200 millimeters as the base of that triangle. So our first question says, what is the length of the drawn altitude of the enlarged triangle? Round your answer to the nearest millimeter. And B says, what is the length of the drawn median of the enlarged triangle? And round your answer to the nearest millimeter. So we're basically finding the length of this altitude and the length of this median in the blown up or enlarged version of this triangle. So if you want to pause here and try and work on it on your own, go ahead and do that before we move on. Okay, so putting the problem to the side here so that we can keep it in front of ourselves, we're going to set up our proportion. Remember, we have parts of similar triangles here. Once we have our proportion set up, we're then going to cross multiply, which will get our usual cross multiplication here of 39 times x, meaning 39 and x on this side of the equation, 29 times 200. Now what we end up with once we product those out, we have 39x equals 5,800. So now we're going to have to get the x isolated, and we do that by dividing both sides by 39. So we'll have 5,800 divided by 39. Okay, so taking our problem again, we then end up with x equals 148.717. We're told to round our answer to the nearest millimeter. So this is in millimeters, that's what we're measuring in. So we want the nearest whole millimeter. We're rounding up, so we're going to end up with 149 millimeters. All right, next problem, guys. We're to find the error. Who made an error in this group project here? Jeremy and Elisa are constructing dilations of rectangle ABCD for their geometry class. Jeremy draws an enlargement of FGHJ that contains the points F at -3 and 3 and J at 3 and -6. Elisa draws a reduction of KLMN that contains the points L at -3 and 3 and N at -2 and 2. Which person made an error in their dilation? Explain. Okay, so the first thing that you should notice is that it contains the points -3 and 3 in the enlargement and -3 and 3 in the reduction. Now if you look at our original figure here and you count out to 1, 2, 3, going up 1, 2, 3, the original figure has a point at -3 and 3 as well, and that's a B here. So we're going to end up with some lines crossing over each other as we get an enlarged figure and a smaller figure that fits inside this box, this original box here. And we're going to try and figure out which one of these students made a mistake. Is it the enlargement that was made by Jeremy, or was it the reduction made by Elisa? So what we do here is we're going to put this problem to the side, and we're going to build our proportion. So I'm going to draw out this rectangle over here for you. This is going to be our enlargement. Excuse me, this is actually going to be our original rectangle here, and we're going to count out how many spaces or what the length of this side is, and we count 1 box, 2 box, 3 box, 4 boxes actually creates this side of the rectangle up there. And what about the height of the rectangle here? How many boxes? We've got 1, 2, 3, 4, 5, 6. So we've got 6 for this side of the rectangle. So our first ratio here is 4/6, but that can actually be reduced down to 2/3. All right, so we've got a scale here of 2/3, and what we're doing essentially is we're checking to see if these figures are similar. So let's take a look then at the enlargement. The enlargement of the rectangle has point F over here and point J down at the bottom. How do I know that up here is point F? Well, point F starts in the same location as point B, -3 and 3. So I know that that's going to be in this corner here. And when we followed J, J comes out to +3, -6. So I know that it moves in this direction and comes down. So I know that it's going to be the opposite corner that they've given us there. Now, in this smaller box, we also have L and N. These are the figures that have been given to us. So let's go ahead and rework that out so that we've got our enlargement here of F with -3 and 3 at that corner, and J with 3 and -6 at this corner. So how do we get to figure out whether or not this is proportional to the other figure, our original figure? Well, what I want to do is I want you to notice that if we have our x here, okay, what I want you to notice is that if we have our x here at -3, That's not changing because we have a regular rectangle. It's not tilted at an axis at all. There's no diagonal lines, straight up and down. If we have -3 as our x for point F here, then that means that this line up and down is x equals -3. Whatever points that you put on here, the y will change, but the x will always be -3, which means that we get down to the point over here, our point at the bottom right hand corner will have a -3 for the x as well. And we'll see that in just a little bit. But also notice that with this same point, we can determine that the top portion of our rectangle will always have the line y equals 3, which means whatever the x value is, the y value of our coordinate will always be 3 so long as it lies on our line that is the top side of our rectangle. Then on this side over here, we can say that the x value for this side will always be 3 because of j over here. J tells us that no matter what our y value is for a coordinate on this side of the rectangle, the x value will always be 3. Okay, so we can actually determine, because the x value and the y value will always be 3, that at this corner where they meet, it is going to be the point 3, 3. All right, and this bottom side of the rectangle, we can also determine from point J, is -6. So y equals -6 is the line that determines the value of the bottom of our rectangle. Any point on it, the y value will always be 6, just like we've done with all the sides so far. So we can determine that if x is always going to be -3 and y is always going to be -6, where they intersect at this point, the point is going to be -3, -6. All right, so we've actually built our rectangle now. You can actually see that we have all the coordinate points for it. If we wanted to draw it out through the coordinates, we could at this point. I just want to make sure that you know that we can actually build this and we can check all those numbers. So once we've done that, we can actually determine what these sides are here. So if we're starting with our side of x and y, we're trying to determine what the value of the movement is on this, counting it out just like we did before. If you move from here to here, say -3 to 3, then we're going from -3 to 0, that's 3 spaces, to a +3, that's 6 spaces. And if we're going up and down, then we're going from a +3 to a -6. So +3 to 0 is 3 spaces, 0 to -6 is 6 spaces. So we end up with a ratio of 6 over 9. That's the length of this side over the length of this side, 6 over 9. But we reduce that down to 2/3. And just like our original figure, we have the same ratio. Both of them reduced down to 2/3. So this problem we've already checked is proportional, and Jeremy is not the one that's made the mistake. We know that the other one made by Elisa, the reduction, is the one that is mistaken. But let's go ahead and verify that. Let's check it just a little bit and see what we end up with. So with her reduction here, we have the points L and N, and I'm not going to look at it too in depth. What I am going to look at here is I'm going to look at her points, which are -3 and 3. So if we start from the 0 here and we count -3 and 3, we end up at that point B again. That's where her L is. But her next point is -2 and 2. So 1, 2, 1, 2. So her square fits entirely in one box, and it is a square rather than a rectangle. It has a scale of 1. It doesn't go anywhere into these other boxes. You don't have to count out the length of each side because each side is only the length of one unit. So it's a scale factor of 1, which is not the same as our 2/3 that we received over here. So this proves that Elisa's reduction is mistaken. She's made the error in her dilation, And so now we know which one is definitely in error. So let's move on to the next problem. All right, photographs. Tracy is 4 feet tall and her father is 6 feet tall. In a photograph of the two of them standing side by side, Tracy's image is 2 inches tall. So we've got Tracy at 4 feet and her father at 6 feet. Although their images are much smaller, the ratio of their heights remains the same. How tall is Tracy's father's image in the photo? What is the scale of the photo? All right, so putting that over to the side here, we can actually determine with our proportion here, we have 4 feet over 6 feet equals, and they give us the height of Tracy in the picture as 2 inches tall. And here's X, which is what we're looking for, which is the height of her father in the picture. So then we can actually simplify 4 over 6 here to 2 over 3. Notice now that we're dealing with feet and inches, but we're looking at it as it transfers to the scale. 2 feet equals 2 inches here. So what about 3 feet? What will that be? If 2 is in the top, well, then 3 is on bottom and 3 is on bottom on both. So X is going to equal 3 inches. All right, so her father is 3 inches tall in the photo, but let's take a look at what we've got going on here. We've actually trying to determine what is the scale of the photo, and we've got 2 inches for every 4 feet here. So because she's 4 feet tall, and she ends up being 2 inches in the photo, we then know that every 4 feet is represented as 2 inches in the photo. But we actually need to convert this into all inches in order to figure out the proper scale for it, so that we can have one unit and not have it inches and feet both in the scale. So let's say that for every 4 feet, there are 12 inches in every foot. So 4 times 12 equals 48 inches. And our new ratio is going to be 2 inches to 48 inches, or over 48 inches. That can actually be reduced down to 1 inch over 24 inches. So our scale is 1 to 24. Next problem. Carlos makes a map of his neighborhood for a presentation. The scale of his map is 1 inch to 125 feet. How many feet do 4 inches represent on the map? Carlos lives 250 feet away from Andrew. How many inches separate Carlos's home from Andrew's on the map? During a practice run in front of his parents, Carlos realizes that his map is far too small. He decides to make his map 5 times larger. What would be the scale of the larger map? All right, now that I've read through the whole problem, we're going to put it to the side, and we're going to take a look here. So we're told that our scale is 1 inch to 25 feet. So we put that in our ratio, 1 inch over 125 feet, 125, excuse me. And then we want to know how many feet do 4 inches represent on the map. And I've set up here the 250 problem as well. So we're setting up this proportion in inches to feet. I want that to be clear. For B, we're going to do 1 inch over 125 feet equals X over 250 feet. So let's take a look at A. A is very simple. We simply have to find out how many feet do 4 inches represent in the map. We have 1 inch for every 125 feet. So 4 times as many, 125 times 4 equals 500. 500 feet will be represented by 4 inches. So here we have B set up, which I already had set up on the page, sorry for that. But we have our proportion here of 1 inch over 125 feet equals X over 250 feet. So now we need to cross multiply, and we end up with 125 times X equals 1, times 250. Everybody knows 1 times anything is itself, so we're just going to end up with 250 on this side of the equation and 125x on this side of the equation. Then what we need to do is we need to isolate x by dividing both sides by 125, and we end up with 2 inches. X equals 2 inches. So in answer to B, Carlos lives 250 feet away from Andrew. How many inches separate Carlos's home from Andrew's on the map? Only 2 inches separate those houses. Let's take a look at C now. During a practice run in front of his parents, Carlos realizes that his map is far too small. He decides to make his map 5 times as large. What would be the scale of the larger map? Okay, so we already put this problem together before. We took a look at that. What we want to do now with the 1 inch over 125 feet, ignore this side of the picture right now, but we had 1 inch over 125 feet was the scale. So what is 5 times that? Well, it just means that we're looking at 5 inches representing each 125 feet. So instead of we don't multiply both by it, we're only increasing the one that we're changing, the map that was representing the actual number of feet. So the actual number of feet remains the same, but the map itself is going to change because now for every 125 feet there will be 5 inches representing that, and that can be simplified down to 1 inch over 25 feet. So the scale there is 1 inch now to 25 instead of 5 over 125, or over 1 over 125, which made the map far too small. All right, let's move on now to the next problem. Actually, that is all, folks. We are done. So if you have any questions, feel free to email me. Please ask me any questions that you have. I know some of you are having a little bit of difficulty with these. Make sure that you're watching the videos. Make sure that you're looking over the examples that are set up in there, going through them with me. If you still have trouble, let me know what you're having trouble with, what problems you have. I've only heard from some of you I have not heard back from yet. I'm glad that those that I have heard from are doing well. You seem healthy and you're getting your work done. I'm going to get grades back to you soon on a lot of this stuff. So good luck to you on your test and stay healthy out there, everybody.